Good morning. It is April 7th. That is Tuesday, and this lesson is for pre-algebra. Okay, and today we are on 13.6. I hope that work is going well for you. It's kind of a lot to take in, but once we get the idea of finding the area and the circumference and the perimeter of shapes, then when we're working with these solid surfaces, we just need to be able to break them down, cut them apart, and lay them flat. So keep that in mind as we get started. Today we're going to talk about a pyramid. Now a pyramid always has a flat surface, so this would be a square as I start to build this three-dimensional piece. And then it has a point like this. Okay, let me see if I can do that a little bit better, that back one. Okay, so you can kind of see my pyramid. It is now a three-dimensional object, and you can see that it's made up of triangles. So this one's made up of 4 triangles. Okay, and while all these triangles aren't the same shape on my drawing, if I were to lay them out and I said that this side is equal to this side on the base, we would know all of those triangles are going to be exactly the same size triangle. Okay. So let's go ahead and look at example 1. They give you some formulas, but unless you're into memorizing a bunch of different formulas, it's really easier in the long run to break down the shape and to find those areas that you're capable of finding. So let me get a different color here. Let's look at example 1. And it says find the lateral surface area and surface area of the square pyramid. Now remember, lateral surface area is just the area going around the sides of the shape, right? And the entire surface area is including the area of the base. Okay, so let's go ahead and find the lateral area. So they give us this shape. They give us, well, you know what? We'll just use this one because it's a square pyramid. Square meaning the bottom is a square and it comes to a point, so it's a pyramid. And it gives us the dimensions of 10 meters, 10 meters, 10 meters, and then do you see that 12 meter that's in there? That is actually, if I were to draw a point here and I was to come straight down to the middle of the pyramid, that would be the height of the pyramid. So if I was standing right in the middle of that square and I went completely up to the point, that's the height of the pyramid. Okay, so it kind of looks like that back one is 12, but it's not. It's the height. So the height is 12 meters. And then on there, you're going to see this slant line that comes down right here and makes a right angle. And they're saying that this slant is 13 meters. Make sure you look at your picture because it's a little bit nice and a little bit more neat than mine. Okay, so what do we need to find the lateral area? Well, I'm going to take this shape apart and I'm going to see that I have 4 triangles. Okay, I'm going to make this one really big so we can work with it. But once I know the area of one, I'll know the area of all of them and I can add them together. Okay, so let's just look at the triangle. I know that the triangle, the base is 10. Okay, and if I were to look at this triangle, I can see that the line that's in the middle that goes to the point that makes a right angle that is perpendicular is 13. Correct? So I know that this one is 13 meters. So can we find the area of this triangle? Yeah, you bet. Okay. Let's do that by saying that the area of a triangle is 1/2 the base times the height. Okay. And I'm going to switch my book here and turn my calculator on. And 13 times 10 equals 130. And I'm going to divide that by 2. And I get 65. Okay? That means 65, 665, 65, 65. So it means that all of these triangles, so I'm going to take my 65 and I'm going to multiply it times 4, and I'm going to get 260. So the lateral area equals 260, let's do meters squared. Let me check. We got it right. I'm doing it a little bit different from them because I feel like this process helps you understand a little bit better. So I don't really have a good answer key, except just to see if we got the answer correct. Okay, so now I need to find the area of the base to find my total area. So I'm just going to add in that square base. And we know that a square is just the base times the height, length times the width, or square a side squared. So 10 times 10 is 100. Okay, so I'm going to take my 100 and add it to here. So my total area equals 360 meters squared. Good. We got it right. Okay, so kind of the same idea is that you were doing the other day. Okay, let's look at example 2. Okay, so example 2 says find the slant height of the square pyramid. Now the slant height, remember when we had that pyramid, if I was standing in the middle of the square of that pyramid, right, this is the height. So if I'm standing in the middle of the square and I put my hand straight up and touch the point, that's the height of the pyramid. Now if you'll remember the slant height, let me do this. Go ahead and, sorry, now all of a sudden I'm struggling to draw a pyramid. Okay, let's do it like this, and then, okay, the slant height, if you remember, was starting at the point and it slants down and makes that perpendicular with the side. So this is what they're wanting us to find, okay? So let's look at example 2. They tell us that the height of the pyramid, that's that height we're talking about, is 24 meters. Okay? Then the base of the pyramid is 20. Oh, they didn't give us a measurement, so we'll use units. Okay? And then, do you see that within there they give us the little dotted line and it says 10. Okay, that's going to be really important. And they want us to find the slant. So I'm going to go ahead and draw it like this. Okay, so this is looking at this pyramid. So instead of looking at kind of down on it at an angle, we're going to flatten it out and we're going to pretend we're standing in front of the pyramid. If we were standing in front of the pyramid, we would only see the front face, wouldn't we? So what we're seeing is that the distance all the way across is 20. But if we half that in that perpendicular, then it's going to be 10. And this slant piece that we're looking for right here is actually this slant piece right here. Okay? So what I've done is I've just taken this, do you see this triangle within? And I've taken it out and I've just drawn a triangle right here, a right triangle. Okay? So, what we want to do now is to find the slant height, we have to find basically the missing length of the perimeter of this triangle. Now, if you'll remember, to do that, the two legs, we take a squared times b squared equals c squared. Okay, so 24 squared plus 10 squared. Be really careful that you're just taking this part of the triangle and not 20. Just this leg. Excuse me. Equals c squared. Okay, so let me grab my calculator and let's go ahead and solve that. So 24 times 24 times 24. I almost made that mistake. 576 plus 100 equals c squared. So this equals 676 equals c squared. Now we need to take the square root of both sides. So I'm going to pop that in my calculator. Second square root of 676 equals 26. So c equals 26. So this side equals 26. Okay, so I hope that made sense to you, and we got that correct. So how would I write this answer? I would say the length, the length of the slant height is 26 units, because we didn't have a measurement there. Okay, let's move on. Next, we're going to be looking at a cone, okay? So let's dissect a cone for a minute and see what we get when we're dissecting a cone. Red's hard to erase. Okay. So when we dissect this cone, we want to see the shapes that it makes. And actually a cone is a little bit different. I think for a cone, if we cut that cone in half, it makes this weird kind of shape. It doesn't make a circle and it doesn't make a square. So for the cone, we're going to have to use the formula, which is the same if we use a circle, right? Some we have to use that formula for because we have to have pi in it. So if we're doing a cone, and we want to find the lateral surface area, okay, then we're going to use this formula. Lateral surface area equals 1/2 CL, okay? So what does that mean? Well, the CL is the area of the circular cone is equal to half the product of the circumference of the base and the slant height, okay, L. Okay, so this equals the circumference of that bottom, so the circumference of this circle, okay, and the L equals the slant height coming down. So this is C and this is L per se. Okay? So slant height. Okay. Well, what is circumference? We want to break that down. Now, if you remember that the circumference is 2 pi r. Right? Believe. Okay? So 2 pi r is what the circumference is. Okay? So let's write this down. We have 1/2, and then we're going to plug in what we have for our circumference, 2 pi r times the slant height. Okay? Well, if I multiply 2 times 1/2, I get 2 over 2, which equals 1. So I get pi r L. Okay? And if you'll look, that's their second formula. So the second formula, so you can use this one if they give you the circumference, but if they don't give you the circumference, then the second formula for it is pi r L. Okay? This being the radius of the circle and this being the slant height. So radius and slant height. Okay, so we can really pick from either one of these to see which one we want to use for our problem. So in example 3, what do they give us? They give us the radius of the circle. Do you see how they give us just this little section of 3? And they give us the slant height. Did they give us the circumference? No. So I want to use this formula because they did give me the radius and they did give me the slant height. So the lateral area of this cone equals pi times 3 times the slant height, which is 10. So we get 30 pi. Pop that into our calculator. Okay. I think they're just leaving it like that. Interesting. So our lateral area is 30 pi. And then we are going to find the total area. Now the total surface area says that the surface area of a circular cone is equal to the sum of the lateral surface and the area of the base. Well, that makes sense. We found the area going around. Now we just want to add it to the area of this base. Okay, so we want the base plus the lateral area. And we just found the lateral area, which was 30 pi. And now we need to find the area of the base. Now remember, the area of a circle is it's pi r squared. Pi r squared. Okay? And our radius is 3. So we would have pi 3 squared, which is 9 pi. Okay? So we come back up here and we put it in. 9 pi plus 30 pi equals, I'm going to jump down here. Sorry, let me block that out. Equals 39 pi. And if we put that in our calculator, then we should get 122.5. Okay? And that would be units squared because we're finding area. Okay? All right. We have one more example, and this is the surface area of a sphere. There's actually no lateral because there's not a shape that goes around and it doesn't sit on a base. So think of a basketball as a sphere. Okay? And sphere, the formula for a sphere is the sides equal 4a. So for a sphere, the area equals 4a. Well, what does this a mean? It says the area of a sphere is equal to 4 times the area of a great circle. Okay? So I want you to see what a great circle. I want you to think, what's the biggest circle that I can make inside that basketball? Is that at the very top before it widens out? No, it's going to be right around the middle of the basketball, isn't it? So if we were to take this sphere, then this circle that would sit inside the sphere, right? Or if we cut the basketball in half and we turned it on its side, we would see a circle, wouldn't we? A hollow, indented circle. So it's this circle in the middle that's the that we want to find the area of. That's the greater circle. Okay, so if we were to look at example 4, we would see that the radius of the greater circle is 8. Okay, so how do we find the area of a circle? Well, it's pi r squared. We did that over here. So let's do pi r squared. And our r is 8. So 8 times 8 is 64. So 64 pi. Now let's go ahead and plug that in. 4 times 64 pi. 64 times 4. 16, carry the 1, 24, 25, 256 pi. Okay, so we get 256 pi. We can multiply that times 3.14 and we will get 803.8 feet squared. And that is the surface area of a sphere. Make sure maybe take a card and go back through this chapter. Make sure you're writing down all of the formulas and a plan, because we just keep coming back to that area of a circle, circumference of a circle. How do we find the area of a triangle? And those things just compound, so it's really important that you have that information. All right, so you are to your work for today. It wants you to fill out the chart of formulas. I'm not going to have you do that. I'd rather you put the important ones that we need onto a card. But I do want you, let's see. Let's do 1 through 26 today.